So now I want to talk about our wheel brake assemblies, and we'll talk about them a little bit more in detail here. So two common types of wheel brake assemblies. You have a disc brake assembly or a drum brake assembly. A lot of times too, like I say, disc brakes in the front, drum brakes in the rear, although it's more common nowadays, increasingly more common to have four-wheel disc brake. The disc brake, what we have is a brake rotor or brake disc, and then the friction linings are called brake pads. And then with a drum brake assembly, we'll have a brake drum, and then the friction lining is called a shoe. And so in this case, brake drum and a shoe, brake rotor or disc, and a pad. So they look completely different from each other. I'm going to start off by, well, and I should say real quick, clamping force on a disc brake system, friction linings come from the outside in and clamp in and slow this brake disc down, which stops the wheel. With a brake drum, they're pushing from the inside out to make contact with the drum and slow the wheel down and ultimately stop the car. This is a typical drum brake here where you see your friction linings of your brake shoes. A drum would be over the top of that where you can't see any of this. And so want to look at a video here. The video that we're going to look at is a drum brake video there, and one of the things that I'll say about this video, and I'm not, is that I don't watch a lot of videos and I don't really endorse a bunch of videos. You'll see we don't do I'm realizing the irony of this as I'm shooting a video. In class, I typically don't play a lot of videos. I want to explain it the way that I want you guys to understand it, and so I typically don't grab a lot of videos to show off of the internet. And a lot of the reason behind that too is that there's a lot of misinformation, and there is even in this video. And so I'll make a correction to that. The info in this video, the main reason why I will show this video is I'm trying to show something dynamic that you usually don't get to see. And I want to make sure that you understand the way that this would work on a car, because we don't usually get to see what happens inside the drum because it would not be visible. And so in a couple cases with this drum brake and with disc brakes as well, where I'm going to show a video here, and then I want you guys to see it and the way that it would operate and function. And so one of the errors that they make in this video is they talk about what do they say? They call it a self-actuator. What they're referring to is a little self-adjuster that as the brake shoe linings wear out, that it will kind of self-adjust. Self-actuating is a different property of drum brakes, and so we'll clarify that a little later. But self-actuating is basically the idea that as these brake shoes apply, the harder that drum tries to rotate, the more biting force those shoes have, and they self-actuate in that regard. A self-adjuster is a completely different process and concept, that the self-adjuster will adjust as linings wear to keep it out in contact and to keep the proper clearance between the shoe and the drum. And so don't want to confuse those terms, but we'll go ahead and play this video. What I want you to pay particular attention to is the way that the hydraulic fluid comes out and the pistons expand, and how one shoe will bite in and shift over and apply the other. That's called servo action. That's one of the things that I want you to see, is how one shoe bites and applies the other. And so we basically go from the shoes not being applied to being a nice perfect circle, and as they apply they egg shape and then bind up, which is why that in combination with the self-energizing property and servo action, where one shoe helps apply the other, a drum brake system actually generates a ton of friction without a lot of application force. And you can tell that by how small the pistons are in these wheel cylinders. It does not require a lot of application hydraulic pressure to apply a drum brake. So for that reason, they're not a crappy brake system. They are not as good in some respects as a disc brake because of their susceptibility to brake fade. But if you consider that most of our semi-truck and trailers are using a drum brake, they generate a ton of friction and they work well as a brake system to stop the car. I actually don't even mind sharing with you as well. I had a 1960 Willys wagon, kind of a Jeep fan. I've had several Jeeps over the years, but I had a 1960 Willys wagon that I had 35-inch tires on it, and I had drum brakes all the way around on that truck, and no power brakes. So I didn't have a vacuum booster or hydro boost system. I had nothing for power brakes, and I could stop those 35s just fine. No power brakes, and when they were adjusted up well, I could stop it just fine without any power brakes because drum brakes make a lot of friction. So I want you to see this video. We'll go ahead and play that here. The sound, I'll turn the sound on so the sound comes through, and we'll play this video.
In drum brakes, the wheel cylinder, with the aid of hydraulic pressure, forces brake shoes out against the drum to create.
So pay special attention to the fact that as the wheel cylinder expands and applies, we get this shoe that will apply and bite in, and then it's going to kick over and apply this other shoe here. So that's some of the application. I'm going to let it play out after this, but I'll stop it here and make a couple of points. This drum assembly is a servo style of drum. One of the ways that you'll know is that there's no anchor pin like we have on this one down below. There's an anchor down below that does not let this shoe apply the other. So this is a more modern drum brake assembly that is called non-servo. This is servo, what's displayed up here. Both of these drum brake systems, this one and this one, have self-energizing properties, but this one has servo action and this one does not. Because one shoe helps apply the other in this case, they generate a ton of friction and it can be uncontrollable, where you get a higher tendency of different amounts of friction from a different wheel, and you can have a car that starts to pull. That if this one makes more friction over here than this one, then it will pull towards the side that makes more friction. And so you tend to have pulling problems with systems like this because they just go to town and make friction. Well, if they don't make the same amount of friction, then you can have a car that starts to pull. They got away from using this style probably by the 80s-ish, mid to late 80s, where if you were going to see a drum brake, they were usually a non-servo drum brake like this, where the anchor was at the bottom. And since the anchor was at the bottom, they couldn't put the self-adjuster down there like you see there. So then they moved the self-adjuster up to the top. So when you see it anchored at the bottom, it's a non-servo. The self-adjuster would be up at the top here where this bar is for our emergency brake. Self-adjuster down here on this one. This is a servo-style brake system. On a servo-style brake system, one of the other things that you'll see is if you look at this in this diagram, and in this video, if you look at the amount of friction lining, it starts here and comes down and ends about there. And on this one, it starts way up here and ends about there. And you'll see the friction lining is not the same on a servo-style brake system. They have what's called a primary shoe and a secondary shoe. The primary shoe always goes towards the front of the vehicle and the secondary shoe towards the back. So that's the way that it should always be put on. When you get a set of brake shoes in a box, you'll have two that would look like this one, two that look like that one, and all the holes would be the same. So if you're not paying attention, you might put the two matching ones like this on one side and the two matching ones like this on the other side. That's one of the things you have to watch out for your customers, as they don't recognize the primary or that vehicle would have a primary and a secondary shoe. And they can often screw that up. And so pay attention, the primary shoe always towards the front. And so in this case, this brake assembly here would be for the right or the left side of a car. So use your imagination to where you would place this while I take a drink of coffee. So this would be for the left side of a car. So that would place this primary shoe towards the front of the vehicle if it was on the left side of the car. So you can see the little imaginary lines we drew it across. We've got more lining there. So that's our secondary towards the back, primary towards the front. On a non-servo brake system like this with the anchor down at the bottom, adjuster up at the top, then a lot of times on systems like this, the brake linings would be the same, and these just kind of butterfly out and make contact with the drum, and it gives a lot more control over how much friction is generated, and you're less likely to get pulling problems from uneven friction out of these. Yeah, I'll leave that there. I'll play the rest of this here.
Friction and slow the vehicle. The main components of drum brakes are brake shoes, the friction that contacts the brake drum; brake drum, the round cast iron housing that's used to stop the vehicle with the brake shoes; wheel cylinder, the component that forces the brake shoes out to the drums; return springs, springs used to retract the brake shoes; and the self-adjusting system, which automatically readjusts the distance the brake shoes need to travel to contact the drums as brake shoes wear down. When the pedal is pressed, pressurized brake fluid at the wheel cylinder actuates pistons to force brake shoes out against the brake drum. When the pedal is released, return springs pull the brake shoes away from the drums and push the cylinder pistons back into their bores. Drum brakes are also self-actuating. As the brake shoes wear down, they must travel a greater distance to reach the drum. When that distance reaches a certain point, a self-actuating mechanism automatically reacts by adjusting the resting point of the shoes so that they are closer to the drum.
So that's our drum brake system there. The couple of good points, got to see the dynamic movement of that. The self-adjuster down at the bottom adjusts out. One of the common problems with the drum brake system is that although it does have a self-adjuster, they usually don't self-adjust. And so a really common issue with drum brakes is they come out of adjustment. Because it's not taught very much anymore, what you'll see a lot of techs do to adjust drum brakes is they'll throw the drum up on the car and they spin it, and then you'll see them bang on it to try to center the shoes, and they spin it and bang on it. Then they'll pull it off and see how much it drags. If you deal with older techs in the industry, they know how to adjust drum brakes properly. Very few people take the time to do it. But where it is still done often is in the medium and heavy duty, like semi truck and trailer. If you've ever, if some of you may have some experience in driving trucks like that and having to check slack adjusters and things. But basically, the process for it is the right way, that you end up adjusting the shoes all the way out till they make contact with the drum. Then you back them off the same amount. Now, that may mean that I go and click this adjuster out. There's an access hole through the back on the backing plate that I have a brake spoon that's kind of like a bent screwdriver or like a pry bar almost, but slender. You can come back through and grab the little adjusting wheel on here. This is a little wheel right here that'll have a little cutout behind it. I can go and ratchet it, click, 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 until it comes up and makes full contact and you can't turn the wheel anymore. Then you would come in and back it off the same amount. And maybe you say you adjust it all the way up and you back it off 5 clicks. Well, you do that for every single wheel, and now you have brakes that are adjusted up identical. All right, so that would be the proper way to do it. Obviously, it takes more time to do that, which is why a lot of techs do the spin and bang method type of stuff. But that would be the right way to adjust up drum brakes. So, drum brakes, we've already talked about how our wheel cylinder is what gives us the application force to apply the brakes. This is a couple of properties that we have for drum brake systems, where we have our self-energizing. Basically, once they start to bite in, the harder that rotor tries to turn, the more they bite in. And the servo action is where one shoe helps to apply the other. And so those are some properties that we have, and then I've addressed the non-servo style where the anchor is down the bottom, then they usually move the self-adjuster up top. So our self-adjusters often don't work. Brakes come out of adjustment. When they come out of adjustment, because there's more clearance between the shoe and the drum, then it takes more pedal travel to where that shoe finally makes full contact and we can start building pressure. And so a common complaint from that would be to have a low pedal. When a customer comes in and complains of a low brake pedal, the first thing that I'll go back to do is just adjust the brakes and check the brake adjustment if it's got drum brakes, because 90% of the time, if you fix the adjustment of the brakes, then the pedal comes back up to the top. I've never had to mess with like the emergency brake cable if people's e-brakes don't work and things like that. It's usually also just a drum brake adjustment. The one of your tip-offs that the brakes will be out of adjustment is that if you go and hit the emergency brake, it'll just zip, and then nothing, doesn't apply the brakes. You can put it in gear and it just takes off right away, even with the brakes applied. Our wheel cylinder is going to be a hydraulic component for our drum brake assembly. The emergency, I'll talk about it. It doesn't have to do with, this is our hydraulic component. I'm going to at least just switch back to this slide. But this over here is our emergency brake lever. It would be cable operated. A lot of the manufacturers nowadays, what they will have done for an emergency brake is, you'll notice if they went to 4-wheel disc brakes, then on the inside of this brake rotor, we call this a hat rotor because it would just fit over the top of everything like a hat. But on the inside of this is like a little drum area. A lot of manufacturers have started to make an emergency brake shoe that would fit inside that little area on their 4-wheel disc brakes. And then that's how they would keep 4-wheel disc brake and be able to have an emergency brake that works a heck of a lot better than what a disc brake emergency brake typically does. So there's advantages and disadvantages to everything. For a drum brake, the advantages would be their self-energizing property, the servo action. Park brakes are simple and they work freaking well. The disadvantages is they're much more susceptible to brake fade. You put that big hat of a drum over everything, it just traps heat like an oven. Require regular brake adjustment, and then because their brakes come out of adjustment relatively easily, they're much more susceptible to brake pull, where you have uneven amounts of friction that are applied to each wheel. The parking brake system, like I mentioned, has to be mechanical. System does not typically require hydraulic pressure, so in that it has to be a separate system from the foundation brake or service brake. And then on cars, they're usually mechanical, provides a way of holding the wheels when you're in park. So then we get to our disc brake system here. So a disc brake system will have our brake caliper. There's a variety of different ways, from floating and sliding and fixed calipers, which we'll talk about. And then you have your brake rotor or brake disc. So the caliper this way system, we've got a rotor sandwiched in between two friction linings, which are called pads. Then you've got a little square cut seal, piston seal there, which is what keeps fluid in, and then also is what retracts the piston after brake application. Line coming in, and the bleeder should always be at the top. If somebody installs a caliper upside down, then it would have the bleeder on the bottom, and they would not be able to get all the air out of their brakes. I've had customers come in that they knew enough how to put the brake calipers on their car. They installed the right caliper on the left side and the left one on the right side so that the bleeders were upside down. Couldn't get the air out of the system. I saw it as soon as they drove up in the driveway and mentioned what was going on, looked at it, and I was like, well, they're going to pay me for what I know. Because if I would have told that guy right away, hey, you put your calipers on upside down, that's why you can't get the air out of them, right? And if he was capable enough to put the calipers on, then he could switch them back and forth. So I'm going to wait till he leaves, make my diagnosis, write it up, call them, and then a lot of times once you have it, they'll pay you to fix it too. But it's not to my advantage then to just tell them while it's in the driveway and let my money and time spent just drive out of the driveway. So this is a floating pin that is your fixture that mounts that caliper to your knuckle. So This is a exploded view of a caliper. What we would call an exploded view diagram in this. So friction material here are pads. They often have some sort of hardware to keep the pads from sliding around inside the caliper and making noise. There's our little square cut seal, a dust seal, piston, and then the body of your caliper with your bleeder. Got a couple of videos for you here, same as what we had before. So on this one, what I want you to see on this, we'll start actually with this one. But on this one, the biggest thing that I want you to see is this is a sliding caliper. So I have pistons just on this side. And what you'll see is as the pistons apply, the pistons come out and apply and push on one side, and then the body of the caliper will slide on a slide pin and pull the outside pad into contact. And so it happens kind of quick. So I'll probably rewind it a couple of times so that you can see it. So you'll see the pistons coming out over here. They'll do kind of a cutaway view. So pistons come out and apply, the body slides over there. Pistons come out, apply, the body of the caliper slides over. All right. So on a floating caliper that way, then that's what takes place on a floating caliper is the pistons come out and apply the pad on one side, then the whole body of the caliper comes and rakes and pulls the other one into application. So the pistons move this way, the caliper body slides on a pin and moves the other way. So that's how that one would work. Then on this style, we've got a fixed caliper, which they typically use in performance applications, or if they want to generate a lot of application force, then they'll use a fixed caliper. And so I'll pull this one up, and we'll watch this one. The music in these is obnoxious. That's why I have it turned off in the voiceover. So this is a fixed caliper, pistons on both sides, usually used in racing applications or performance applications there because they can generate a lot more friction. One of the things I want you to see in this is we get to see quite well the way that this brake square cut seal will deform and then retract the piston. So they'll do a close-up of it here in a minute. So applying the brakes, pistons come out, and hydraulic fluid pushes the pistons out. In this upper area here, you can see that it starts out square and it'll go diamond shape and deform that square cut seal, and that's what will retract the piston when brake pressure is released. So deforms, brake pressure release will retract the piston. So this is our floating caliper that would float on some guide pins that as the piston comes out and applies this pad, the body would rake over and pull this pad into contact to generate our friction to stop this vehicle. The square cut seal we're seeing would deform. So as the piston slides out to make contact and push the pad into contact with the rotor, then when brake pressure is released, then it will pull the piston back. These become self-adjusting and self-cleaning because any dust that's generated gets blown away, where with a drum system it's trapped. Then they also self-adjust because as the friction lining wears off, then the piston just slips out a little further past the seal and just falls into a new range of deforming and retracting. So pretty simple system here, doesn't require a ton of maintenance. Some of your advantages of your disc brake systems would be that they're pretty much fade resistant because they're exposed to so much open air that they can get rid of heat pretty quickly. And so they're pretty fade resistant, self-cooling, self-adjusting, self-cleaning because the dust just blows away. Disadvantages is it requires a ton of application pressure, which is why you see the pistons are so much larger than that of drum brake systems. No servo action, no self-energizing. Because they generate so much friction, they generate a ton of heat. They usually become quite susceptible to brake squeaks. Poor park brake performance. So, which is why a lot of them have moved to a system like I was showing you earlier, where they make a little mini drum inside of the head of that rotor. So, brake system problems that are common to see. Pulsating pedal, we've talked about warpage, where the rotor is not true. And because of hydraulics being what they are, if this rotor doesn't rotate true and it beats the piston back, then as it pushes the piston back, the piston pushes the fluid back, which pushes the pedal up inside the car. And so as it chases this thickness variation, you get a pedal that pulsates. And the faster you go, the faster that pulsation is. So typically what I would do to diagnose pedal pulsation is I get a car up to about 50 miles per hour, and then I start to lightly press the brake. And if I feel the pedal come back and hit me in the foot, then I can tell that the brake rotors are warped. Most of the time the front's warped, although we'll check run out and parallelism to prove which one it is. A lot of times at slower speeds, I could find the issue was with drums, because you kind of feel it come from the back of the car and make it low. The other way you can isolate rear from front is because the emergency brake is typically on the rear axle. If you use the emergency brake to apply the brakes on a drum brake system, then you can feel it in the emergency brake and apply the drums. That's also very useful for noises. So when you hear brake noises, a lot of brake pads will have these little tattletales or warning indicators on these pads. You can see it on this one that would have a warning indicator there. And if people ignore that long enough, then they get, instead of just the squeak, usually they'll squeak a little more when the brakes are not applied, but this will sit there and drag and kind of, and then when you apply the brakes, it'll go away momentarily. But if they ignore that squeaking noise, then it turns into this, which is what freaking money sounds like I was telling you before. That is not like nails on a chalkboard. That is money. So the price just goes up. By the way, this rotor used to look like this one. So you can see how thin that one is. You can see the little slots and ribs inside this one. That one whole side of this rotor is gone. And so that person drove it until the pistons popped out of their calipers, which some people will do. And if they do that, do not let them drive that car out of your shop. They can tow it. They can tow it themselves. They can call a tow truck. They can tow it. They cannot drive it. That is a huge liability, and they may go right down the street and kill somebody else's, family member or something. Do not let them drive it out. I've also told you, I had people like, well, you can't stop me from taking my car. Like, I'll call the police. I'm like, go ahead. If they'll pull you over and give you a fix-it ticket for a taillight burn out, what do you think they'll do if you can't stop your car, right? So don't feel like a jerk. It's doing the right thing. Protect the people in your community. That's the right thing to do, in my opinion. I'm not making them pay me to fix it. I'm just telling them you can't drive a car that you can't stop. One of the other things to just be aware of, you can see that this is a riveted pad. So I've got a couple of brake shoes that show this well. This one is a bonded one. You can see there's no rivets in it. It's glued on. This one is riveted. And so I want you to see the linings on this are about the same. But the one with rivets will touch before we have all the lining worn out. When on one that's glued on, it will go all the way to the backing plate over here, right? Or all the way to the backing plate of this pad. They call it a frame on the shoe. Where on this one, it can go all the way down to the frame or the metal part of this. Where on this, before it even wears all the thickness that I can see of the lining off, it's going to touch a rivet. So you want to be careful. Riveted pads may look like they have more material than what they actually do, or riveted shoes. So be careful about that. We only have as much friction lining as to the point that we can touch the rivet. Some of the squeaks that we get is from that somebody doing a brake job and not washing the rotors like we talked about. Other times you take them apart and you see that. Other times, one of the things that you got to watch out for as well, you can hear this one, right? So what's taking place on the back side of this, if I can kind of turn it a little bit where you can see, there's a backing plate here that kind of keeps rocks from getting in here, or water from splashing directly on this. And so, but a really common thing that happens that people aren't paying attention is this little thin sheet metal backing plate will get bent to where it touches the rotor. Make sure that you always look down, make sure that it's clearanced out, and if it is touching, you just bend it back. Just bend it out of the way so that it can't touch anymore, but make sure you watch out for that. But sometimes your backing plate on here will start to rub up against the rotor and it'll squeak. Really common entry-level tech mistake. So you make sure on the brake jobs that you do, that you look down the side of that rotor and make sure the backing plate or that our little like splash shield, dust shield is not touching the face of that rotor. You'll end up with a squeak. Brake bleeding we talked about our two-person method. There's also power brake bleeders where you hook air up to it and there's a special adapter for each master cylinder. A lot of dealers will have those. In some independent shops, we have one, but because it requires a special adapter for every master cylinder cap and all the different caps they have, you're typically limited on what you can use it on, and it can make a big old mess if you get it installed on one that doesn't leak. And if you spray brake fluid and get it on somebody's paint, it'll orange peel their paint like bam. So make sure you're super careful with brake fluid. We don't drip it on people's paint and stuff like that. But brake bleeders are super nice, one-person method. You hook up a line with a special cap adapter, then you just go to each wheel and crack them. And you can bleed brakes like that with a system like that. When you are doing a two-person method, then you start with the one furthest from the master cylinder. This is another example of a one-person method where when you do this setup, what you do is you get a line, you open the bleeder and you get a line down and fill up a jug with brake fluid. And because every time I apply the brake, it'll push fluid out, and when I release it, it would suck back in. Well, if this is hanging out in the air, you suck air back into the system. But if it's hanging out into a can of brake fluid, then all the bubbles I push out, the bubbles float up to the top, and every time I release the pedal, it just sucks brake fluid back in. And so it's a way that you can do brake bleeding one-person method in that regard. I want to talk a little bit about anti-lock brakes, and we'll wrap this up here. So with anti-lock brakes, what we have is we've got a wheel assembly that is basically tracking a wheel speed sensor that is tracking all four wheels. So our anti-lock brake system has got a module that is watching all of the wheel speeds. And when the brakes are applied, the system becomes active. So it's considered passive. It's just watching wheel speeds when the brakes are not applied. But once you apply the brakes, the system goes active. And it'll start watching the wheels. And if we were going 60 miles per hour, then it's watching them as you apply the brakes, 59, 58, 57. And if you have up three wheels that start counting down, 56, 55, and one of them goes to zero wheel speed, then it knows that wheel locked up. Because you were applying the brakes, it knows the brakes are in play. When it sees a wheel go to zero, it knows it locked up. Now, what it will respond is it's got a modulator assembly that can control, typically, brake application to each wheel and a pump motor. And so it will bleed off the brake pressure to that wheel so that wheel can start turning again, and then it'll reapply it. And it can do that over 10 times a second. And so it's very quick. And what an ABS system does is once we've had a wheel that locks up, or if all the wheels lock up, then we start to skid in the direction that we have momentum. With ABS, it doesn't necessarily shorten the stopping distance, but while your wheels are locked up and you're in a skid, you cannot control the vehicle. And so if we can keep our wheels in contact with traction with the ground, then we can actually maneuver the car and avoid accidents while we're braking. Where if you did have a brake assembly that were to lock up, we would just start to skid. And so it's a way to maintain control of the vehicle and traction with the ground during braking and have the potential at least to avoid an accident. And so where if we were just in a skid and your system, you did not have an ABS system, then what you should do if you start to skid is release the brakes so the wheels can start rolling again. Once you get traction again, you can reapply. Before the days of ABS, everybody knew how to do that. But now with ABS, you don't even have to think about it. It might freak you out if you've never been in an ABS stop. If you apply your brakes hard enough, then you actually will feel the pedal kind of pulse, and you'll hear your pump motor kick on, a buzzing sound, and you'll feel the pedal kind of pump up and pump down. You just stay in it, and then it goes into an ABS mode where it'll apply the brakes for you. So, and keep them from locking up into a skid. So that's our last slide here. We'll have to go along with this, we'll have a brake inspection lab that goes with this where you go through and do a brake inspection. Before you ever do any brake work, you should always do a brake inspection because we need to know, are the brake rotors within a service limit where we can machine them, or do they need to be replaced? What other kind of issues? Is there a hardware problem there? And try to understand the condition of a customer's brake system so that you can get them a proper estimate together. Is there enough material left on that rotor to machine it? Do we see any other issues? Some of the issues that you'll see sometimes that we watch out for that I haven't addressed in this video is things like brake lines. They have ribs down these lines so that when this brake caliper is installed, I can tell whether that brake caliper line is twisted. And so it's on a longer line like this, it's pretty easy to see that it would go like this. And if I follow the rib lines all the way down, I can see that there's no twist in it. But you can see how a customer could go like this, all right? And so I always watch for that in my brake inspections because they can get it back mounted on with a kink in it. And if you pull it tight enough, I can pull that kink back straight, all right? So I watch for that, make sure that there's no twist in the line whenever you do your brake inspections. Make sure that there's no leaks is part of it. And then we look and measure our friction lining, how much we have left. Look at our rotors and make sure that what condition they're in. Are they warped? Are they not parallel? You see any hot spots in them? So if you see discoloring of the rotor, where this one does not have it, but you'd see blue spots. When we get metal real hot, it'll turn blue. If you see blue spots in it, you can't machine it. It gets replaced. If there's cracks or splits in this, it gets replaced. If it's too thin, it gets replaced. One of the other things that we watch for is our linings. Couple of things. These linings came right off of the same car, and so this friction lining and this one, you can see that this lining is worn down to nothing, and this one I still have a lot of friction lining on. That is caused by basically one of two things. If the piston is seized in the bore, then in that case, what you can have is it only applies the one in our seal, or it'll only apply this outside one, for example, what will cause this, wiped out on one side, still good on the other, would be this. If the square cut seal does not retract the piston. If it doesn't retract the piston, then what ends up happening is, like, for example, this one, which you can see the imprint of the piston here, it was applying this one and then would not retract, so it wore this one off because it would drag this lining off. One of the other things that would cause it, if you remember, that when this one came out and applied, it would pull the body over and apply this one on a floating caliper. If the slides are jammed up and seized, then we would only apply this inside one off the piston and the slides would not work to pull this outside one. That would cause that. If you get, for example, a set of brake pads that are wiped out on one side or the other, it can be a couple of things. If both pads are wiped out over here and this side looks brand new, one of the things that can happen that way is the piston is seized to where only, if it's seized over here, only this one works, and so these brakes never apply, and it only applies these and wipes these out. It can also be a case where the slides are jammed on this side to where I generate more friction over here than over here. And so want to make sure that you understand, you see pads that are worn out like this, it's a problem with either the piston or the slides. When you get on the same caliper, one piston or one pad that's good and the other that's wiped out, it's a problem either with the slides or the piston. The way that you diagnose it, you take the caliper off and check the slides. If the slides are free and they move in and out freely, then it has to be the piston. You replace the caliper at that point. Good enough. Every time we surface rotors, we wash them, soap and water, make sure, or drums, always wash them with soap and water. When we do our inspection, we'll tell the customer how much lining thickness they have. You cannot give them a mileage estimate. You can only tell them, you have 50%, or you have 30%, or you have 10% left, or you have 80%. You can't tell them how many miles because you don't know how they drive. They may drive like a maniac and then wipe out a set of pads in 15,000 miles. Or they may be one that babies their car and they're never in a hurry, and so their pads will last them or shoes will last them a really long time. You never can tell them mileage. You can only tell them percentage or how much thickness they have. There's one other thing I wanted to say before we wrap it up. Yes. We can look up and see what the normal thickness dimensions are of anybody's brake pads. And so in doing that, that will help us determine how much percentage of linings they have left. Don't be fooled. Some manufacturers, their friction linings start out really thin. They may only start with, 7 millimeters or so of friction material, to where when they're at 3 millimeters, they're a little less than 50%. And so you don't want to oversell customers parts like that. And so you'll kind of learn that they're using a really hard material, and that manufacturer has they start with a thin pad to begin with, or thin shoe. Where you'll kind of figure it out is sometimes you'll go and sell that brake job because they're at 4 millimeters or something like that, and then you get the new ones out of the box and you're like, oh dang, those are really thin again. Call the customer back and do the right thing, and don't just continue on because you sold it. Call them back and let them decide if you want to or not, and tell them, hey, look, I made a mistake. These ones come pretty thin, and make it right. One of the other things that I wanted to advise you on as well is what brake pads are good to buy. All right. Dealer pads are always good. They tend to not squeak very often. They tend to last a long time and not make a lot of brake dust. That tends to be true of all the dealer pads. And believe it or not, when you go and buy pads from the dealer, they're often not really that much more expensive. And sometimes they're not more expensive than a good quality set of pads at a local parts house. So myself, I can buy pads for my 4Runner for like $60 at the dealer. Why would I buy anything else at that point? A good quality pad doesn't make a lot of dust. The other ones that I'm a big fan of, which tend to be harder to get nowadays, is one that's called a Wagner Thermal Quiet. Now, Wagner Thermal Quiet is a really great pad, in my opinion, because they don't squeak. One of the differences in these is if you look at the back of the lining, the backing plate of this pad, they actually push some of the friction lining material through to the back to where I don't have any metal-to-metal contact on the back side, so that eliminates a place where we often get a lot of squeaks. The downside to a Thermal Quiet is they tend to make a ton of brake dust. They don't squeak, but they make a lot of brake dust. But they're a good quality pad in the aftermarket that I would hold in high regard. Any of the quality pads that you get in the aftermarket will tend to have chamfered edges. I don't know if I've got any up here kind of to show you. I don't. But over here, where that we'd come out with a certain thickness, they would chamfer off the edges, and the tips or ends would be angled down, and that will tend to help reduce some of the feather edging that you get that would start to squeak. This one you can see does not have any of that. It's perfectly square. If this was at like a 45 up here at the tip, then we would say that has a chamfered edge. That's generally some of the stuff that you get from a quality pad. They usually come with new hardware and things like that. Thermal Quiets is a good one. You can never go wrong with the pads from the dealer. Good enough.